Right at the heart of this huge AI revolution, there's a problem. A massive trillion-dollar problem that's hiding in plain sight. It's this wild story of incredible power and just incredible waste. So let's get into it. So you're looking at the engines of modern AI. These GPUs, they're absolute workhorses, right? Capable of just incredible computation. But here's the crazy part. What if I told you that for all that power, most of them are just sitting there, doing nothing, just burning energy, waiting for something to do? And listen, this isn't some small little inefficiency we're talking about. The number is 80%. 80. That's the average amount of GPU capacity just gone, wasted, across the entire industry. So 80% of this revolutionary, super expensive hardware, yeah, it's pretty much doing nothing. Okay, so let's unpack this. People are calling it AI's trillion-dollar problem, and for good reason. It's this massive hidden inefficiency that's just chugging along underneath the entire AI boom. So what's the culprit here? Well, it actually has a name: GPU pre-provisioning. And what that means, in simple terms, is that companies keep their GPUs powered on and fully loaded with AI models, 24/7, all just so they're instantly ready the second a user sends a request. Now you might be thinking, why on earth would they do this? It sounds so wasteful. Well, it all comes down to user experience. We all want our AI chats to be instant, right? Our image generations to pop up super fast. So companies pre-provision to guarantee that low latency, to handle those sudden bursts of traffic, and to always be ready for peak demand. Basically, they're choosing speed over efficiency, every time. And the result of that choice? It's pretty staggering. The moment there isn't an active request coming in, that GPU, which, by the way, costs thousands and thousands of dollars, just sits there, idle. But it's still drawing power, still costing a fortune. Okay, so the obvious question, right? Why not just turn them on when a request comes in? Seems simple. Well, this is where we meet the real villain of our story. It's the core technical hurdle, and it's called the cold start challenge. Just take a look at this quote from Google Cloud. It mentions something called time to first token. That's basically just a fancy way of saying how long it takes for the AI to start typing its answer after you hit enter. In this case, it took them 19 seconds. 19! Just to get the very first word back from a cold start. And get this, they called that impressive. 19 seconds. To you and me, that's an eternity. And this just illustrates the gap perfectly. On one side, you've got the industry standard, what a giant like Google is calling impressive, at 19 seconds. And on the other side, we have a new technology from a company called InferX, and they're doing the exact same thing in less than half a second. It's not even close. Yeah, let that sink in. This isn't just a small improvement, this is a seismic leap. We are talking about being over 38 times faster, 38x, than what the industry considers a good benchmark. That's insane. So the big question is, how is this even possible? How did they do it? Well, it all comes down to what InferX calls their big breakthrough. They've basically cracked the code on true on-demand AI, without all that crazy waste. The magic, it turns out, is in their GPU snapshot technology. So look at it this way. Instead of loading an AI model from scratch every single time, which is super slow, they get a GPU perfectly set up, and then boom, they take a snapshot of its entire state. Everything in its memory, they save that snapshot. So when a new request comes in, they don't have to go through that whole painful, slow boot up process. They just instantly restore that saved state. It's kind of like resuming a paused video game instead of having to start it all over from the main menu. It's genius. And let's be clear, this isn't some simple little trick they figured out overnight. This is patent-pending technology, the result of over 6 years of super focused R&D. And it's what lets them restore even these huge complex models in under 2 seconds. And by doing that, they just flipped the entire equation on its head. They turned that 80% waste into 80% productive utilization. Okay, so let's zoom out for a second. Because when you solve a problem this fundamental, you're not just improving things a little bit. No way. This has the potential to completely remake the entire economics of the AI cloud. And here's why this should matter to, well, everyone. If you're an enterprise using AI, this means you can run the exact same powerful models, but for a fraction of the cost. And for the cloud providers, the big guys, they can suddenly serve 5 times the number of customers using the exact same hardware they already have. I mean, it's a total win-win. And you can bet the market for this is not small. We're talking about the AI inference market, which is just the technical term for actually running the AI models. That market is already worth over $100 billion, and it's projected to more than double in just the next 5 years. Just let that number sink in for a moment. $254 billion. That is the size of the market that right now is operating with 80% inefficiency. It is just absolutely ripe for disruption. Their plan to actually capture this market, it's pretty clever. They're offering a free open source part of it, which makes it super easy for developers to jump in and start using it to build trust. But the real magic, that proprietary engine that gets you those sub-2-second cold starts and unlocks all that efficiency, well, that's the paid product. So all of this kind of brings us to a final pretty big thought. The AI revolution is here. That's obvious. It's changing everything. But what happens when we make its most fundamental building block 80% cheaper? Just like that. What happens to the speed of that revolution? What new kinds of applications suddenly become possible? I mean, what new worlds is that going to unlock?